Welcome to Brain Vision.
Let's go ahead and use the chain rule here. So you see U depends on X, Y, and T. So that's why we have these three lines up here. And then each of X, Y, and T can be thought of as depending on alpha, beta, or gamma. So let's go ahead and find this one first. So how do you go from U to alpha on the tree? You start at U and then you either have to go X, Y, or T, and then from there you go to alpha. That should be a T, not a Z. And then derivative of T with respect to alpha. Okay. So now we have some derivatives to compute. This one first. It's e to the ty, and then derivative of x with respect to alpha. Go ahead and use the power rule there. And then up next over here, derivative of u with respect to y. And that's a times. Derivative of y with respect to alpha, and we can see here that y doesn't depend on alpha, so that's just 0. And that'll make this whole term go away. Derivative of u with respect to t. And then derivative of t with respect to alpha, and that's gamma squared. So now let's go ahead and plug in these values here. And you can see that we still have a little more work to do because we still have to find what x, y, and t are equal to. So go ahead and plug in these three in the formula of x, and then we could work this one out together. You get alpha squared, so that's -1 squared times beta. Y, that's going to give you 2 squared times 1, so that'll give you 4. And then similarly, z should give you -1. So let's plug in these values here. So we have e to the, sorry, and that's a t, not a z. Okay, so plugging this all in, e to the ty, so that's e to the -4, and then 2, and then alpha times beta, that's -2. And then we have y times x, so that's 8, and then e to the ty, and then gamma squared, so that's just a 1 squared, so it's just 1. And so putting these together, we have -4 e to the -4 plus 8 e to the -4. Simplifying gives us 4 e to the -4. So all this work, and this gives us the first partial derivative with respect to alpha. And I'll go on to the next page and do the same type of work, but this time with respect to beta. So go ahead and use that tree diagram that we have. Okay, so going from u to gamma, u to beta, this is one way, this is another, and this is another. Now, we already computed these three, so there's no work to do there, but we still have to find the remaining. So the derivative of u with respect to x, we already found that to be e to the ty. And now the derivative of x with respect to beta, so recall x. Let me write these out on the side. So you see the derivative of x with respect to beta is just alpha squared. Derivative of u with respect to y, we found that to be this. Derivative of y with respect to beta, use the power rule. Derivative of u with respect to t, we found this on the previous page. And then multiply that by derivative of t. Oops, sorry about that. You could see here that the derivative of t with respect to beta is 0 because there's no beta in this equation. So that eliminates that term. And let's recall the values that were given. And that these implied we already showed this work on the previous page, so let's go ahead and plug all this in. E to the ty, so that's e to the minus 4. Alpha squared is just 1. And then we have tx, giving us a negative 2. And then e to the minus 4, and then 2 beta gamma. So that gives us e to the minus 4, and then we have over here, that's 4 and then minus 2, so that's minus 8. Giving us negative 7 e to the minus 4. So let's go on to the next page. We have one more. And using the same idea as before with the tree diagram, we have the following. So that's a gamma there that I just wrote. Let me go ahead and fix that. Okay, we've already found these on the very first page, so we could just write these in. Now let's go ahead and recall the formula for x, y, and t. So x was given by alpha squared beta, so we see that the derivative of x with respect to gamma is just 0. And that'll eliminate the first term. Okay, up next, we already found this. This is tx e to the ty, derivative of y with respect to gamma, that's just beta squared. This one we found already, and derivative of z with respect to gamma, use the power rule. So let's once again recall the values that were given for alpha, beta, gamma, and that these implied x is 2, y is 4, z is -1. So let's go ahead and plug all that in. So we have tx So tx over here giving us a -2, and then e to the -4 times beta squared. And then we have xy, so that's an 8 there. And then 2 gamma alpha All right, so here we have a -8e to the -4. And then here we have another, no, this time we have -16, giving us -24 e to the -4.